In this video, I want to discuss the three-step problem-solving method, which your book describes in section 2A. Now, in your textbook, this three-step process is not something that every mathematician would use. However, these three steps kind of simplify the process a mathematician might go through and will guide you through your problem-solving process. Now, just to be funny, you may have seen memes like this before, and they might remind people of how they feel when they look at a confusing math problem, where it maybe even seem like it's in a different language. But these three steps are intended to help you through that process and feel more confident when problem solving. For step one, we emphasize understanding the problem. So take time to actually think about what the problem is asking about. What does it want you to find? And look at the information that has been given. This does take time. It's common for people to feel uncomfortable with this process. The mathematician, it might seem like they just look at the problem and they instantly know the answer, but that's not at all true. They spend years and years of building that comfortability level with just taking the time to read through a problem and sort the ideas. So don't be afraid if this takes you a little longer than it might take other people. Take that time for yourself that you need to read through that problem. Some ideas. So locate some key words that were in the prompt. You might draw pictures. While this seems kind of silly sometimes, this can often help you organize your ideas. So don't be afraid to draw pictures. So if things seem like they're all coming at you at once, take that time to kind of sort the ideas and draw a map between the concepts. So if I was given a problem that my units were in terms of yards, and I know that my answer is supposed to be in terms of inches, well, somewhere I might need to look up conversion ratios in order to actually solve this problem. And so thinking through what the answer should look like, what the solution maybe unit should be in, sometimes that can help you work backwards and understand what you need to find in order to solve this problem. So again, understanding the problem is step one. For step two, you want to spend time solving the problem. In this part of the process, you will carry out required steps and calculations. Be careful in your work, so take a few minutes and you might even try different methods. Don't be afraid again to give this some time. Try to keep your work organized, so when math teachers ask you to show your work, that's to encourage you to use appropriate mathematical steps. So follow order of operations. Be sure that you have a reason for every step. You should never feel like you're just mimicking someone else's thoughts or guessing when you're doing these calculations. You should be able to have an appropriate mathematical reason for every single step. You might not need to take all of the steps that another student may need to take, and that's fine as long as you have appropriate reasons for why you're taking each of those steps. Double check your work. So sometimes I might even do a problem twice just to make sure I didn't make an algebraic error. And yes, I have to make time to do that, but sometimes that can help you catch an error. If I do a problem one way, that does not mean it's the one and only one way to do a problem. You might think differently and you might have a completely appropriate method to solve that problem where we come to the same solution but with a different thought process. I encourage you to practice coming up with your own processes. So if I teach something one way, that doesn't always mean that it doesn't usually mean that my way is the only way to do it. So especially with real world problem solving, I want to encourage you to have different approaches. As you're working these problems, bring your experience to the problem solving process. So if you have some real world experience that can help you recognize maybe errors or recognize if an answer seems far off from where the values it should be at, then bring in that outside experience. So step 3 is to explain your results. This is where we want to encourage you to improve or develop your reasoning, your problem-solving reasoning. So ensure that your result seems reasonable. If you're calculating a measurement for something that should be very small and your measurement seems very large, then often catching that, because it seems unreasonable, that will help you maybe catch errors that you made in step 2. practice explaining your reasoning. So sometimes in class, your teacher may ask you to just explain yourself. It doesn't necessarily mean you're wrong. It's just to develop that mathematical reasoning. And again, make sure that you could provide a reason for every single step. You should never feel like you're just guessing. You should be able to have a reason. And again, bring in your real world experience. So check, does your solution really match real world examples? And if not, then you might look back through your work and see if you did make an error. So again, the 3-step problem solving process is to understand the problem, solve the problem, and then explain your results. And we want you to keep this process in mind as you do work the problems through chapter 2.